Okay guys, in this video we're going to be taking a look at a situation in which we might actually apply some of our knowledge of quadratic graphs to an application. And so let's go ahead and start by reading this problem here and then maybe kind of tying into how it can be modeled with, say, a quadratic graph. And so we say an arrow is fired along a path that is known as parabolic, or at least in the shape of a parabola. It says the height of the arrow f of x in feet can be modeled by this equation here, where x is going to represent the arrow's horizontal distance in feet. So let's start with this. Since we've read the problem here, the very first thing we want to do is kind of just identify what our variables in this situation are representing. So our variables are x and y, but in this case, we notice over here that it says f of x is representing the height of the arrow and it's being measured in feet. So for part A here, it says identify the variables. We're going to say f of x is really representing the height of the arrow. And with respect to measurement, we're going to say it's in feet. And x, so what does x represent here? Well, over here it says where x is the arrow's horizontal distance in feet. We're going to write here and then our horizontal distance in feet. Okay, this is also in feet. But essentially we've got a situation here where an arrow is being fired and the further away it gets, it goes up and then comes down, but we're modeling it really essentially with this idea that it does this. It's a parabola. So here goes our arrow. On our x-axis here, we can say that this is our horizontal distance that the arrow is away from, say, the person who's shooting it at the origin here. And then we would say that the f of x-axis, the y-axis, represents the height of our arrow in feet. So essentially our situation is kind of just modeling the path of this arrow as it goes from left to right here. So looking at the questions we want to answer, well, the question we want to answer, we say what is the maximum height of the arrow and how far from the release does this occur? So in terms of what I'm being asked to find here, you have to understand that we have an equation that relates y to x, but what we're looking for is the maximum height of the arrow, which when we talk about height of the arrow is looking for the maximum max y value. And in terms of when we find the how far away from the release it occurs, we're finding the horizontal distance that it was away from us when that maximum height occurs. And so we're going to say we're looking for a horizontal distance when we talk about how far from the release. So looking over here on the graph, we would say, well, where does the maximum height of this arrow occur? Well, you might have already recognized that the maximum height is going to have to occur at the vertex here. So I'm going to highlight this point. I am going to write a few things here. We're going to say, first of all, that the x part of this point is going to represent the distance away it was when it reaches our maximum height, but also that our max height is going to occur at the vertex here as the y value. So essentially, when you look at this problem again, it really just becomes a situation where what I'm asking you to do is go find the vertex of this parabola, which is something that we often spend a lot of time doing. Go find the vertex. So if I'm going to find the vertex of this parabola, then we have to recognize first of all what form this is in, and I recognize that this is in what we call standard form, this ax squared plus bx plus c form, where all of our terms are very well arranged such that our exponents go in decreasing order. But what I know about this is if we're going to find the vertex of something that is in standard form, I know that the vertex is located at negative b over 2a is my x value, and I know that the y value is what I get when I plug negative b over 2a into my function. And another thing that can be said here is that our axis of symmetry is also located at this vertical line x equals negative b over 2a, which has to run through the x value of our vertex here. So that's exactly what we're going to do here. We're going to start by saying, well, if I have my equation, which I'm going to rewrite here, we have f of x equals negative, let's see, it's got tenths, hundredths, thousandths, 8,000ths x squared plus 2x plus 4. What we're going to do then is just go ahead and find its vertex values. So let's start with this. We say x equals negative b over 2a. So we're going to want to find our negative b over 2a part of our vertex first, and then go plug that into our function. So let's put in for b here 2, since that's our b value, and then we'll say over 2a, so we say negative 0.008. So with my calculator here, it looks like we get negative 2 over, and I'm going to have to check this out, so let me slide my calculator over here. On the bottom, starting with that, we say 2 times negative 0.008. We should get negative 0.016, and we do. We get negative 0.016. But now what we're going to do is we're going to take our negative 2 here, it's on top, negative 2, and we're going to divide by this number here, negative 0.016. And what we end up with is 125. So first things first, I'm going to write 125 here. As a matter of fact, I'm going to say x equals 125 is our axis of symmetry value. And so up here on my picture, what I could also acknowledge if x equals 125 is my axis of symmetry is that the x value of our vertex is also at 125. So what this now becomes is a situation where we say, okay, well, I need the y value. Well, recall that your vertex, if we know the x value, we can find the y value by plugging this or substituting this input into our function. So what this is going to mean is we're actually going to need to go and evaluate for 125 as an x value. So if I put 125, say, into a table here, what we end up with is this. We get negative 0.008 125 squared plus 2 times 125 plus 4. This is a 5 here. So we get this here, and we do need to evaluate for it, but if I'm being honest with you, we're just going to probably go grab a graphing utility to help us do this. So typing this in exactly how we say negative 0.008, and then in parentheses I'm just going to put my 125, and that is squared. And we say plus 2 times, in parentheses, 125, plus 4, and I'll hit enter here, and what I discover is this. Essentially, it's at a height of 129 feet when it's 125 feet away from us. So I'm going to write our vertex values again here and say, well, then my vertex is at 125, 129. And recall that this was the most important thing of what we're trying to find here. So if we know that our vertex values are 125 and 129, then what we need to do now is actually write in a conclusion. And so that conclusion essentially is going to state what we could conclude from these two vertex values. And knowing that the x represents its horizontal distance and its y represents its maximum height here, we're going to say that the maximum height of the arrow is 129 feet, and it occurs when the arrow is 125 feet away from the archer. So when you explore problems like this, okay, you'll see these problems where it says, maybe what's the maximum height of a projectile and where does it occur. Essentially what I want you to recognize is that we are looking at quadratic situations if it's a projectile. And if we're looking for a maximum height, it's always going to occur at the vertex. So these problems really just became a find the vertex problem and know what form you're in so that you can find the vertex. But once you find the vertex, you'll be able to answer the couple of questions that I'm asking, like how far away was this arrow, say, for instance, and how far high in the air was it, or how high in the air was it. Cheers.